Hey everyone, and thanks for joining. I'm extremely excited to be here and present the tale of Wix recent CI migration to Buildkite, the challenges we faced, and how we managed to solve a massive bottleneck in our CI system. But first things first, I'm Shai. I'm backend engineer at Wix Infrastructure Group. And usually those slides are hard for me. What should I say about myself? Well, I like to play video games and so on. But the thing is that 1 month ago, my wife gave birth to our firstborn. So this time it was relatively easy to build this slide. It means three things: that I'm a proud father to an adorable new baby, and that I'm no longer a gamer, but probably an ex-gamer for now, and and the third thing is that most of this presentation was built at really strange hours, so I hope that at least some of it makes sense. Um, let's start with some numbers. Um, in Wix, we have over 2,000 microservices in production, and the state changes roughly every 4 to 5 minutes. We have over 400 deployments per day, and in the backend guild alone, we are running around 9K builds per day. And in the last few years, massive work was being put into our CI system in an offer in an attempt to reduce the overall build time. Bazel really took our build system to a whole new level. Our migration from Maven to Bazel improved the build time by 90%. That's 90. That's amazing. And there are super interesting posts and talks at the Wix Engineering site, so you are welcome to check it out if you're interested. But if things are running so smoothly, so why are we even here? The thing is that the time that builds are spending in queue before they start to run is not great. And when I say not great, I actually mean pretty bad. When the system is under load, we're talking about 40 minutes of queue time, sometimes even more. And devs eventually come to our Slack channel saying, well, what's going on? My build is not starting, and I want to push a hotfix to production, and I can't. So this is the tale on how, when our system is under load, how we reduce the queue time, the time that build spend in queue before they run, from 40, sometimes 50, sometimes even 60 minutes to merely seconds using Buildkite. So where's the bottleneck? Let's see. In Wix we have a single pull request in Wix triggers several build types. The first type is called branch only. It's super simple. It's just a build, a Bazel build running on your branch. The second type is called pull request rebase, PR rebase. That's simple as well. It's your changes that are rebased on top of the main branch to reflect a build that contains your changes plus the latest changes from master, right? The third type is something called cross-repo checks. It's a bit more interesting. It can be used by developers to identify breakages in other repositories before the pull request is merged to the main branch. That is before they're breaking their colleagues, right? So an engineer can choose to run 0 to n builds as its cross-repo checks that are a part of the pull request itself. So in Wix, n equals 60. We have around 60 repositories of backend code. So for every pull request, we have one branch-only build, one PR rebase build, and n number of cross-repo checks. And after the pull request is being merged to the main branch, we have something called a main build that runs a build on the main branch and creates an RC, a release candidate. Now all of those builds are using the same build queue in our build server. Now not only pull request triggers builds, there's also something called background builds, where during off-peak hours there's a job that triggers main builds that were not triggered in a while. They're the stale builds. So let's agree that we have different build types. Some of them are more important than others, as they are on the critical path to production, right? So main branches builds are more important than background builds, and others behave a bit differently. Some are very bursty, very spiky, right? Cross-repo check builds, where we can trigger up to n builds at once, they are very spiky. So let's imagine a scenario, which is quite common, where we have two developers running pull requests, plus cross-repo checks on all of Wix. Now, this is around 130 builds alone. Now add that to the usual load of our CI system, where developers keep pushing code and running builds, and we have a developer that wants to push a hotfix to production to fix an urgent incident. Now, in the previous state of our system, that build was most likely queued, and queued for a long period of time, because we could not run concurrently more than 200 builds. So very simple day-to-day scenarios that I just described could lead to build storms and to a state where everyone are blocked. There's no way to prioritize builds. There's no way to say, well, this build is more important than that build. And we talked about Bazel earlier. We could not enjoy any of the Bazel goodies. We could not enjoy the 90% reduction in build time because the build is not starting, right? So it's like building a spaceship that does not launch off the ground. So during those incidents, developers are completely blocked. This is a screenshot of a random interval of time, so we can see that those events happening. Sometimes here we see 20-30 minutes, but we can go up to 40 or even 60 minutes. So we quickly understood that we need a new build server. So we created a requirement document and asked ourselves what Wix needs from a build server. We explored multiple vendors and we created POCs, and Buildkite met most of our requirements out of the box. Now, a spoiler, Buildkite amazingly solved the scaling problem that we introduced earlier, but moving to Buildkite, or actually moving to any new build server, introduced a few challenges, architecture decisions and dilemmas that we had to address. So let's start with those and then get back to the scaling issue. So the first thing, we need to define Wix repositories, Git repositories in Buildkite, right, in Buildkite pipelines. So should we create a dedicated pipeline per repo? That means 60 Buildkite pipelines, or maybe we should have one Buildkite pipelines for all of our Wix repositories. If we go with the pipeline per repo approach, it feels more natural. Buildkite leads you towards it. It even asks you for the Git repo URL in the pipeline settings, right? It has a nice breakdown of the trends, the success percentage, build time per pipeline, and it's very nice seeing those numbers per repository. On the other hand, what happens if there's a low-level change in the build steps? What happens if those needs to change and now we need to bulk update 60 pipelines? And also, since Wix is triggering builds using the API, we need to hold a mapping of a Git repository to pipeline slug, so we would know which pipeline to trigger. So eventually we chose the pipeline per repo approach. It works quite well for us. To overcome the challenges from earlier, we maintain a configuration file that holds the mapping, the Git repo to pipeline slug mapping. And we also created a script that bulk updates all of the pipeline in case the build steps would change. But we also took action and explicitly tried to reduce the risk that the build steps will change. More on that in the upcoming section. We'll talk about that in a second. So we have 60 repositories. We have 60 pipelines. What's next? How do we define the build steps? So let's imagine we have a pipeline called Bazel-ecom. Now, when we fire a post call, a REST API call to trigger a build in that pipeline, the steps will run. Now, what are those steps? Usually, it's a pre-built steps like download scripts and so on, and then the bazel command, bazel test / that means please run bazel on my working directory, and then maybe other magic that will run after the bazel command is completed. However, for Wix this is not enough, because we saw we have multiple build types, and every build types behave a bit differently, and we understood that we need a way to dynamically figure out what's the context of our build, what's the context of what we're doing, and which build type should be triggered. So we used BuildKite dynamic pipelining mechanism. It means that we do not hardcode bazel test at all in the pipeline. We do not hardcode anything, right? So we understand in runtime what is the context and what steps should run, and we dynamically load them. But it also allows us a very cool feature, right? We can identify certain conditions and feature flags, and we can say, well, if we're running in a specific repository, for example, ecom, and using in the specific build type, for example, main, please load those experimental build steps. So it helps us to gradually introduce changes. Dynamic pipelining helps us to gradually introduce changes. And the last thing is that we are offloading logic to a BuildKite plugin that we created in order to reduce the chances that pipeline steps will change. Remember that we talked about it in a few minutes. We said that we need to reduce the chance that the steps would change. Now, if there's a change to the code that is dynamically deciding which steps to run, we just need to release a new BuildKite plugin, and that's it. So it looks something like this, right? We have an API call that triggers a new build. In the build steps, we do not have any logic. The only thing we have is a declaration of a plugin that we wrote internally, and the plugin has the logics, has the smarts of understanding what steps will run. If that featured flag is open, please run the experimental steps. If you identify a specific build type, please run those steps. Very nice, but who is triggering those builds, right? We have BuildKite pipelines, and we can load all of the build types that we saw earlier, but who is firing those API calls? Now, in Wix, we cannot allow ourselves to be down. And the CI system should be treated with the same care as the most critical microservice in production. So the migration should be treated with care. And in order to gradually roll out the move to BuildKite, we must have the ability to run builds in parallel, in the old build server and the new build server. And we also must have the ability to quickly roll back. The last thing you want to do is to introduce a new system, migrate specific clients, specific repositories, and then have them blocked because something goes wrong and you cannot roll back. So this is our triggering flow. We are consuming Git events, VCS push or events on a pull request. We have a microservice that is listening to those events. It produces a Kafka message, and then we have a triggering service that consumes those events. Now the triggering service is only responsible for what are we triggering. It does not bother itself with where. So after we are creating a message of what build is being triggered, it is produced to a second Kafka topic, and then we have multiple services consuming that message. We have a legacy triggering server that triggers builds on the old build server, and we have BuildKite triggering service that triggers builds in BuildKite. Now every repository can be in one of three modes: legacy mode, BuildKite mode, and parallel run. Legacy mode means that its build will run in the all build server. Build-kite mode means that its build will run in build-kite. Now parallel run mode means that build will run in the old and new build server in parallel, but the build-kite run will have no side effects. It will not create RC, and the user will not even know that that build happened, right? So it gives us two very, very strong features. One is the ability to quickly roll back every repository with a click of a button. The second thing, which is super strong, is the ability to move all of Wix to parallel run mode and have the exact same load, the exact same traffic that we would have in production, right? That's production traffic, that's real traffic. And then we are able to test what's going on in build-kite, in the new build server. We can measure everything, and the user does not even know that under the hood more and more builds are running in a completely different, in the new build server. So that is very strong for us, and it tremendously helped us during the migration. So nice. What about notifications? We need something to report to GitHub on the result of the builds. You know, those are the magical green checks that every developer wants to see green as soon as possible. Those. So since our status checks reporting logic is complex, some status checks results are aggregates of a set of builds, so it's not really straightforward. So we have our own microservice that listens to build notifications and reports to GitHub. That flow must work flawlessly. Any disruption, any downtime, or perhaps lagging notification is impacting on the dev experience because the feedback loop is longer, or maybe there's no feedback at all. So we integrated with build-kite webhooks mechanism. We have a microservice that is listening to those events. Build is scheduled, build started, build finished, all of those events. And is producing a message to our internal Kafka. And then we have a service that consumes it and fires status checks updates to GitHub. But can we do better? What happens if our service is down? What happens if there's a network issue? There could be tons of reasons on why we can drop notifications, and we do not want that. So we introduced retries. We used build-kite integration with EventBridge, and you can integrate EventBridge to a very large number of targets, and in those targets, in those components, you can define retries, for example, AWS, SNS, SQS, Lambda, and so on. So in case our service is unreachable, messages are retried, and that is very, very important. But you know, we already did the integration with build-kite's native webhooks mechanism earlier in the previous slide. Why not have them both? Why not have event flow from the native webhooks mechanism and from EventBridge, and have a feature toggle at the entrance of our service asking, should I honor EventBridge messages or should I honor the native webhooks messages while defaulting to EventBridge? We actually had an incident where EventBridge events were lagging badly in UAssist 1, and that basically meant that our CI system is down, and all we had to do was just flip the feature toggle, move to build-kite webhooks and not EventBridge, which immediately solved the problem. Now this architecture might change in the future, but it works quite well for us. We identified possible failure points, we added retries, we added a fallback path that we could easily turn on and off when needed. And yeah, so that's regarding notification. Now it's time to get back to build storms. So remember that we have multiple build types that greatly differ from each other. All of them are sent to the same build queue, and they are frequently clogging it. So what if we could assign different build types to different queues, right? What if we would have a dedicated queue for pull request builds as they are on the critical path, and another queue for cross repo checks builds as they are very spiky, right? So that's exactly what we did as we used BuildKite's queuing mechanism. When we fire a build, we are explicitly specifying on which queue it should run. And we also did a mapping of build types to how fast they should start running, to understand and create an SLA and understand what a user should expect. So for example, main builds, they should run as soon as possible, no doubt. Pull request builds, as soon as possible. And background builds, well, since we don't have a user actively refreshing and waiting for his builds to complete, we can tolerate a longer queue time. So we have complete isolation between all of the build types, and main builds are going to the main queue and pull request builds are going to the pull request queue. And for example, in this scenario, a massive invocation of cross-repo checks won't affect the critical flow at all because we created isolation. But now you probably ask yourself, where are those builds running, right? How many agents do we have? How do they scale out? So for auto-scaling, we use Kubernetes and KEDA. KEDA stands for Kubernetes Event-Driven Autoscaler. And a BuildKite build agent is a Kubernetes pod. And we use BuildKite agent metrics to gather data on the number of agents and the number of builds that we have in BuildKite. And that information is exposed via Prometheus. And it is queried by KEDA. And KEDA, there's actually a formula that we're using to calculate the number of desired agents. So for example, if we have 100 builds, we might want to scale out to 120 agents to create an additional buffer of agents. And also based on the time of day. So maybe during the night we want less agents for cost optimizations. So for each queue we ask ourselves, is this queue optimized for low queue time? That means that build will start fast. Or maybe this queue should optimize for cost. If we optimize for low queue time, we want to have a large number of pre-warmed agents. And KEDA will scale out further when needed. If we optimize for cost, we can have no buffer of pre-warmed agents, right? But the trade-off is a higher queue time, but it's not that high, by the way. We're talking about usually a worst case of 3 or 4 minutes of start time because that's the time it takes to spawn a pod. It's obviously not the 40, 50, or 60 minute that we talked about at the beginning of the presentation. Now we can do a quick breakdown of our queues and figure out if they are the critical path, and then we might want to have more pre-warmed agents. Are they extremely bursty? Or maybe we would want to have enough pre-warmed agents to handle the first spike, and then KEDA will scale out organically. It's like having an imaginary slider where you can choose how fast build will start versus how much you're paying in advance. And that is very, very, very strong. But how do you know that your numbers are accurate? The answer is monitoring. We are religiously monitoring almost every aspect in our CI system, and this is no different. Here you can see graphs of agents, how many total agents we have, how many idle agents we have, busy agents per queue. All of those are provided out of the box by BuildKite agent metrics. And let's see queue time metrics, how fast builds start to run. For background builds, since we have no pre-warmed agents, build can spend in queue for a few minutes, and that's completely acceptable. That's the SLA that we define. For cross-repo checks, which is not on the critical path, but it can be very spiky, most of the time builds are starting very fast. But giving a burst of builds, it takes a while to spawn new pods. And again, according to the SLA, that is acceptable. And eventually for main builds, which are on the critical path and there's no doubt they should start as soon as possible, we indeed see that they start very, very fast. So this concludes the talk of how we switch to a new build server gradually, safely, with no downtime, while solving a huge bottleneck in our CI system. So usually this is the part where the Q&A slide kicks in, but unfortunately I would not be able to attend the live Q&A due to time zone restrictions. So, however, feel free to hit me up on Twitter or LinkedIn for questions or comments. Thanks a lot for listening and have fun. Thank you.